Hello guys and welcome back to the reaction zone. In today's lesson, we're going to look at oxidation numbers. Oxidation number is the charge, which can be real or imaginary, which an atom appears to have in combination. There are several rules for determining oxidation number. The first is that the oxidation number of an atom in free elements is 0. It doesn't matter how complicated the molecule is. For example, in ozone, O3, the oxidation number of oxygen in ozone is 0. In nitrogen molecule, the oxidation number of nitrogen is 0 as well. The second one is that in neutron molecules, the algebraic sum of the oxidation numbers of all the atoms present in the molecule is 0. Let's take, for example, the molecule of hydrogen chloride. What this rule tells you is that the oxidation number of hydrogen plus that of chlorine when added must give you what? 0. The third one is that for complex aeons, the algebraic sum of oxidation numbers of all the atoms is equal to the net charge on the aeon. For instance, take the complex aeon that is hexacyanopyrene aeon. What the third rule is telling us is that the oxidation number of iron plus that of cyanide will be equal to the charge on the aeon, which is what? -3. The fourth one is that fluorine has an oxidation state of -1 in all of its compounds. And this is because it is actually the most electronegative element in the periodic table. So irrespective of the compound in which fluorine is present, the oxidation number is always -1. The next one, oxygen. The oxidation number of oxygen is -2 in all compounds except in peroxides. In peroxide, the oxidation number of oxygen is -1. In superoxides, it is -0.5. And in fluorine oxide, it is +2. So, there are only 3 exceptions where the oxidation number of oxygen is not -2. In peroxides, where it is -1. In superoxide, where it is -0.5. And in fluorine oxide, where it is +2. The reason why the oxidation number of oxygen is +2 in fluorine oxide is because fluorine is much more electronegative than oxygen. If oxygen maintains an oxidation number of -2 in fluorine oxide, then the algebraic sum of the oxidation numbers will not be equal to 0. So, oxygen has an oxidation number of +2 in fluorine oxide because fluorine is much more electronegative than oxygen. The next one is that the oxidation number of hydrogen is +1 in all of its compounds except in metallic hydrides. Examples of metallic hydrides are beryllium hydride, sodium hydride. A metallic hydride simply refers to a compound that has 2 components, hydrogen and a metal. Hydrogen is electropositive. However, it is not as electropositive as metals, because hydrogen is a non-metal. In fact, it is the only non-metal that is electropositive. So, when it is in combination with metals in metallic hydrides, it has an oxidation number of -1. So, with the exception of metallic hydrides, the oxidation number of hydrogen is always +1. And then the last one is that the oxidation number of an aeon is equal to the electrical charge present on it. For example, copper 2 aeon, the oxidation number of copper is equal to the charge, which is +2. Another example is Na plus. The oxidation number of sodium in Na plus is equal to the charge, which is +1. Now, having said that, it is important to also know that valency and oxidation numbers do not mean the same thing. We tend to be used interchangeably, but they are different. First, the valency of an element is usually fixed. However, oxidation number of an element varies. In other words, an element will always have different values of oxidation number because it depends on the nature of the compound in which the element is present. Valency is always a whole number. However, oxidation numbers and whole numbers, they can be fractional, they can even be zero. The third one is that valency is never zero, with the exception of noble gases. However, the oxidation number of an element may be zero. And then finally, when writing the valency of a compound or of an element, no sign is attached. In other words, you don't attach a positive or negative sign when writing the valency of an element. However, the oxidation number of an element will always carry either a positive sign or negative sign. So I want to believe that the rules for determining oxidation numbers is clear. And also that you now understand the difference that exists between the valency of an element as well as its oxidation number. Thank you very much and see you next lesson.